Hello. Yes. We welcome you back to PSSB, Physical Sciences. Silver Bullet with me, Richard, here. Yes, today we are looking at this question, a grade 10 Physical Sciences question. It says that write the chemical formula for each of the following. The first one is iron 3 chloride. Okay, we need to know that whenever you see this in bracket, it implies that they are giving you the combining power or valence of iron. Reason being that iron is a transition element, so it exhibits several oxidation numbers or combining powers. So they are trying to tell you that in this very compound, it is iron 3, not any other iron, because there is iron 2 and iron 3. So in this compound, the iron we are having here is in the form of iron 3. That's what it implies. So in other words, we are having iron and its combining power or valence is 3. And we are having chlorine, which is group 17, its combining power is 1. So what happens during the writing of the chemical formula is that the number here is taken up by this. So it becomes the subscript of this. And the number here becomes the subscript of this, the exchange. So in this case, what do we have as the chemical formula? It is iron. We should be having 1 here, but we don't write 1. Then chlorine, and we have the 3. This is iron 3 chloride formula. Okay, let's come to magnesium carbonate. Magnesium, which is Mg, is a group 2 element, and group 2 have 2 as the combining power. Now, carbonate is a radical, so it cannot exist on its own. It must be in the compound. And this radical has combining power -2. Okay? So, because they are the same, what do we do under the circumstance? We ignore them or we cancel them out. So, this one will give us magnesium carbonate in this form as the formula. Okay, let us go to copper 2 bromide. The symbol for copper is Cu, and copper is a transition element normally existing in oxidation state 1 and 2, or having combining power 1 and combining power 2. But here, putting this in bracket, they are trying to tell you that the copper we are having here is having combining power 2 or valence 2. And bromine, being a group 17, has valence -1. So, what do we do? Yes, they exchange. The one becomes the subscript of this, and these two become the subscript of bromide. So, this will give us the formula of this nature, which is going to be CuBr2. Yeah, then we come to this one, calcium nitrate. Okay, calcium, which is Ca, is a group 2 element, meaning that it has 2 as the combining power. Now, nitrate is a radical, which is NO3, having -1, so which is 1 there. And you have to remember that these combining powers are exchanged. This one comes here, and this one comes here, but we don't write 1. So what do? We'll have our chemical formula as calcium. Then nitrate comes, but remember nitrate has 2. The question is, how do you show that the 2 is for both? By having a bracket over nitrate. Yes, we put a bracket because the 2 is for both nitrogen and oxygen. So this is how we write it. Yeah, then we come to this question. It says that write the chemical name of each of the following. So these are the compounds we are having here. Okay, let us start with the first one. SO2. What's the chemical name of that? That is sulfur dioxide. Di implies 2. So this one is trying to show that there are 2 oxygens attached to sulfur. Okay, number 2 is SO3. What is it? That is sulfur trioxide. Tri coming from 3, implying there are 3 oxygen atoms attached to sulfur. Then next we have this one, chromium sulfate. But there's a trick here. Chromium is a transition metal. So even chromium with another valence is also going to be called chromium sulfate. So to differentiate between which chromium you are dealing with, you have to state the oxidation state in which chromium is existing in this compound. And this number is that oxidation state. So the name is going to be chromium bracket 3 sulfate. Yeah, then we come to this one, CuO. Yeah, this is a copper oxide. But we need to know that copper is a transition metal having more than one oxidation state. So if we don't state the oxidation number in which copper is existing here, it might bring confusion. So the best answer here is going to be copper 2 oxide. Yeah, then we come to this one, number 4. Okay, so number 5. It's 1, 2, 3. This is 4. This is number 5. Okay. Yes. So we are coming to number 6. Yeah, this copper oxide. Yeah, it is very convenient and correct to put the oxidation state of this copper. Because if you call it copper oxide, then you might be meaning this. Both are copper oxides, but they need to be precisely identified. So this one is copper 1 oxide. Yeah, because if you analyze, the number 2 is for oxygen, and this oxygen is having number 1. So which means that this copper is existing in oxidation state, which is 1. Then lastly, we come to the last one, which is potassium permanganate. Yeah, then we come to the last one, and this one is called potassium permanganate. Yeah, that is that. And with that, I'd like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, with me, Richard, here. Yeah, we urge you to subscribe, to comment, to like, to share. Yes, we also have to remind you that we have a sister channel for grade 8 and 9 Natural Sciences. The channel is called Natural Sciences grade 8 and 9. So please refer the channel to any person in that level. We believe it will be a very good, useful tool to them. See you next time. Bye-bye.